Hi everyone. In this video, we will interpret the slope and y-intercept of a regression line. Identify whether the regression line for each dataset is likely to have a positive or negative slope. The scores of a standardized test as a function of the anxiety level of the test taker. When dealing with functions, we have a vertical and a horizontal axis. And it tells us in the function notation here as a function of. The second part is the horizontal, and the first part will be our vertical. So we can look at this as anxiety level, and we're comparing it to scores for the test. So as the anxiety level increases, what do we expect to see with the scores? Well, as anxiety increases, people typically stop thinking as clearly and get more nervous, and so scores go down. If we were to combine this down and over motion, we end up with a line in this direction, which is a negative slope. So our first one is a negative slope. The second one states the number of ice cream sales at a shop as a function of the high temperature of the day since the beginning of the summer. So again, let's label our vertical and horizontal axes. The second part is the high temperature of the day, so the horizontal is temperature. And the vertical is the first part, the ice cream sales, because the ice cream sales are as a function of the high temperature. So we're going to put sales here for the ice cream. Now we need to look at, as the temperature rises in this direction, what should we expect to see with the ice cream sales? As temperature rises, people typically want to cool down, so the sales will also increase, which if we combine the two up and over, we get a line in this direction, which is a positive slope. Our third one reads, the number of cases of an infectious disease as a function of the density of the population in an area. So let's again give ourselves our vertical and horizontal. The second part, when it says as a function of, so we have the population density down here. So that's our horizontal population density. Then for the vertical, we have the number of cases of infectious disease. So we're going to put disease here. Now, as we see the population density increase, we will actually see an increase of disease because it is easily transferable if there's somebody around. If the population density is small, then you're not going to be in contact with as many people. So we're going to see population density going up and disease going up, which again gives us a positive slope. And now for our last example, the blood pressure level of patients as a function of the minutes of patients' physical activity in a month. So we're going to give ourselves a vertical and horizontal again, where it states as a function of the minutes of the patient's physical activity. So we're going to put, I'm just going to summarize that and write in exercise. And the vertical will be the first part. So this is blood pressure. And we're going to be comparing again, as physical exercise increases, what should we expect to see with blood pressure? Well, hopefully the blood pressure is going down. Now, this is not in all cases, but we're going to take this as a general rule. So as exercise goes up, blood pressure goes down, and if we combine this down and over, we end up with a negative slope. We've now found the likelihood for each of our data sets to have a positive or negative slope, and we're all done.